Welcome to Daily Papers, the podcast where we break down the latest academic research into bite-sized, easy-to-digest conversations.
Today, we're diving into the world of large language models, or LLMs. These are the powerful AI brains behind tools like ChatGPT that can write poems, code, and answer almost any question you throw at them.
They're amazing, but there's a big, looming question that everyone is concerned about: safety. We want these AIs to be helpful, but we absolutely do not want them helping someone with something dangerous or harmful.
Exactly, and the companies that build these models spend a huge amount of time and effort on what's called safety alignment. They essentially teach the AI a set of rules, training it to refuse harmful requests. If you ask it how to do something illegal, it's supposed to say, "I'm sorry, I can't help with that."
But here's where it gets tricky. These big, general-purpose AIs are often customized for specific jobs. This is a process called fine-tuning. Think of it like taking a brilliant university graduate and giving them on-the-job training to become, say, a fantastic video game writer.
You're feeding them very specific examples to make them an expert in one area. The problem is, for a long time, the common belief has been that this fine-tuning process messes up the AI safety training. It's like our new video game writer gets so focused on crafting dramatic stories that they forget basic workplace etiquette.
In AI terms, this is sometimes called catastrophic forgetting. In the process of learning a new skill, the model forgets its old fundamental lessons, like the ones about safety. The result: an AI that's great at its new job, but is suddenly much more willing to answer inappropriate questions.
And for years, the assumption has been that this is an unavoidable trade-off. If you want better performance, what the paper calls utility, you have to sacrifice some safety. It's like a seesaw. When one goes up, the other must come down.
Well, a new paper titled Rethinking Safety in LLM Fine-Tuning, an Optimization Perspective, is here to challenge that entire idea. The researchers from Microsoft Research, KAIST, Oxford, and others argue that this safety drop-off isn't inevitable at all.
They say the problem isn't that we are fine-tuning the models, but how we are doing it. The issue lies in what they call poor optimization choices. In simple terms, it's all about the settings you use during the training process.
Let's use an analogy. Imagine you're trying to perfect a cake recipe. One of the most important settings in AI training is called the learning rate. This is basically how drastically you change your recipe after each attempt.
If you have a really high learning rate, it's like tasting the cake, deciding it's not sweet enough, and then dumping a whole new bag of sugar in. You've gone way too far. Your next cake will be a disaster.
A lower learning rate is like adding just a pinch of sugar, tasting it again, and making small, careful adjustments. The researchers found that when fine-tuning AI using these aggressive, high learning rates can completely wreck the safety alignment. The AI overcorrects and loses all its previous nuance.
By simply choosing more gentle settings, a lower learning rate, a different batch size, which is how many examples the AI learns from at once, they saw a massive improvement. In their tests, a poorly tuned model would give harmful responses about 16% of the time. But with careful tuning, they got that number down to just 5%.
And they did this without adding any new safety data or complicated filters. They just turned the knobs more carefully. It suggests that safety isn't a separate feature you bolt on. It's deeply connected to how the model learns.
But they didn't stop there. Based on this observation, that stable, gentle learning is key, they proposed a simple but brilliant solution. It's a technique called exponential moving average, or EMA.
That sounds technical, but the concept is really intuitive. Imagine you're a professional dancer who has mastered ballet, and now you want to learn hip-hop. Standard fine-tuning is like trying to completely forget all your ballet training to make room for the new style. You might end up being clumsy and losing your balance.
The EMA approach is different. As you learn the new hip-hop moves, you consciously blend them with your foundational ballet skills, your balance, your core strength. You don't lurch from one state to the next. Instead, your new style is a smoothed-out version of the old and the new. It keeps the model anchored.
And the results were fantastic. Using this EMA technique, they reduced the attack success rate, the measure of how often the AI gives a harmful response, down to just around 3%. That's a huge improvement, and it often performed just as well, if not better, on its specialized task.
What's really powerful about this is its simplicity. Developers don't need to find huge new safety datasets or build complex new architectures. They just need to adopt a smarter, more stable training process that respects the knowledge the model already has.
The paper visualizes this with a cool concept called a loss landscape. You can picture the learning process as hiking through a landscape of mountains and valleys. A safe, stable answer is in a wide, smooth valley. It's easy to stay in. But a harmful answer is in a very narrow, steep ravine.
An aggressive, high learning rate is like trying to run down the hill with your eyes closed. You're much more likely to stumble and fall into one of those dangerous ravines. The EMA method is like having a walking stick and a map. It helps the model take a slow, steady path that stays in the wide, safe valley.
So the big takeaway here is that the supposed trade-off between an AI's usefulness and its safety might be a myth, or at least it's not as severe as we thought. It's often a symptom of rushing the learning process.
It seems that when it comes to teaching an AI new tricks, the old saying holds true. Slow and steady wins the race. Or, in this case, it wins the safety race. It's a really practical and hopeful finding for anyone trying to build safer, more reliable AI.